one.
Good afternoon, everybody. Welcome to our episode of Plate Bonding and Unconventional Solutions. These are alternatives to avoiding the hazards of hot work and allowing you to repair structures and equipment that maybe there's just not enough metal left to weld. So plate bonding is a safer, smarter alternative to welding. According to the Bureau of Labor Statistics, roughly 500,000 people are injured every year due to hot work, brazing, and welding. And plate bonding is a cold applied composite repair method where the metal is permanently bonded over a damaged or weakened area of the equipment using our high performance composite repair materials. Some of the reasons to choose plate bonding over welding is you avoid hot work permits as well as just permits in general. So you don't have to get a permit. There's no sparks and flame involved, making it a lot safer. You don't have to worry about arc flash or somebody forgetting to put their welding gloves on and getting burned. You can minimize downtime. It cures fast. You can be back on track safely. And with USI training, we can help your guys get the job done and help you better utilize your entire skilled trade workforce in case all your welders are tied up on other projects. And many times it is thicker than welding, so it's non-corrosive and allows you to basically repair something safely and effectively. We have different materials you can use for plate bonding. And I won't really go into detail about those. That's where you can just call one of our technical consultants and ask them if 105 would be better, 106, 101, or even our 302 systems. But they're basically solvent-free, so you can use them in confined spaces where maybe, especially if you're welding on stainless steel. Stainless steel has cadmium in it, which can make it very hazardous. And as most of you know, if you're a welder, I don't claim to be a welder, but I know enough about welding that I actually sold it and won a trip to Ireland for selling welding rod. And if you're ever welding on cast iron, that can be very difficult to weld. And the question is, do you preheat it? And then if you preheat it, do you preheat it evenly? How do you preheat it evenly if you're out in the open? And how do you let it cool down evenly? Here's a good example of some plate bonding. We can see at the base of the tank, they had some corrosion. And ideally, it's best to lower the tank to where there's no fluid coming out because that makes it more challenging, and it becomes more of what we call a make-do repair when we're trying to glue something underwater with our Resimac 106. But in this case, they were able to empty the tank for a minimal period of time and use our Resimac 101 paste to glue on the steel plate. So you're actually repairing it with steel. And once it's cured, the product's machinable and gives you good long-term protection. I'm down here in the Dearborn River Rouge area, and there's a place called Fritz Aluminum where many years ago they had a pipe that was thinning from the outside due to all the acids in the air. And we actually did a composite repair over 100 feet of pipe, and they were hoping just to get 6 months to a year out of it. And I remember going back to their facility 4 years later, and it was still in service on their natural gas pipeline. 5 easy steps. The big key to getting this done is surface prep. And as my mom would say in real estate, you only need to remember the 3 L's: location, location, location. And when it comes to plate bonding, you only need to remember the 3 S's: surface preparation, and more surface preparation. So it's best to degrease the surface. We have a product called USI Universal Cleaner to get rid of oils, grease, and contaminants. If it's deeply embedded with oil and grease, where possible, you'd want to get a torch and pull the oil out of the steel if it's impregnated with a lot of oil. Then you want to mechanically abrade it. You basically want to make sure the product has peaks and valleys to bite into. Usually we're looking for 2.5 to 4 mils. You want to then position the plate over the area, make sure it fits properly. and then you'd mix the product according to your technical data sheets. And you'll see here over on the right, there's a tank roof where it looks like they used a needle gun, and then they used a plate and they bonded that plate on. And then you'll want to apply firm pressure to it for at least 20 to 30 minutes, depending on the application and the materials you use. We do have our 106 and 104, which set up a little bit faster. So those you can apply at 68 degrees, and they're going to give you about a 4-minute pot life, and then you'll want to apply firm pressure. I've seen people use 2x4s to apply firm pressure, and I've also seen people use clamps, and basically allow the product to cure, and in some cases we'll even come back with more of the Resimetal 302, 301, or 101 or 106, along with fiberglass mesh or what we call reinforcing tape to give it extra strength. And when appropriate, you might even use heat to cure it out. I was up in Manistee, Michigan, last week, actually, last Monday and Tuesday, and it was an extremely cold June last week up in northern Michigan, so we had to bring in turbo heaters to help us cure out the product because we were lucky if the days got above 60 degrees. So that's really the 5 steps to it, and then a final inspection. Here's a good example of us using our 106 FF to bond a plate onto a pipe that was thinning. And then you can see we came back with more 301 epoxy resin, actually 302, and some 703 glass tape, and we're adding hoop strength, as well as we're taking out some of the pitting in the other areas to give it even greater corrosion resistance and chemical resistance. Here's a nice example of the gas processing unit where we restored it using the 101 followed by some 501. And here again, we're doing some plate bonding to help you out, make it easier. And this was actually a job done by Lindy near the Marathon Refinery in Detroit. It was an abandoned line where they just wanted to keep water from getting into the pipe. That you can see here was had quite a few dents in it, 2 dents it looks like, and one where it's holed all the way through. And unfortunately for this client, it rained all day, so they were down in a ditch with their mud boots on. Not ideal situations, but Tim was able to use his knee to secure the plate to the pipe. And then you can see here they used some reinforcing tape for added hoop strength and corrosion resistance. And then their standard is to put something called Viscotech over all piping that's exposed. So they came back with Viscotech wrap along with Viscotech PVC outer wrap to make a nice long-term fix for them at this facility. So that's really plate bonding in a nutshell. So Chris, why don't we open it up to Q&A and go from there.
Opening up the mics right now. All right. If you have questions, feel free to unmute yourself, and we'll get to those.
I have a question. Can you use this system for like load bearing repairs, or is it better suited for like containment and sealing options?
When you're thinking load bearing, what are you referring to? Because it does give you roughly, the 101 gives you roughly 15,000 psi of compressive strength, and we have used products like this to create a non-slip surface. I'm actually over at the near the F-150 plant right now, and I remember back in 2007, 2008, we used some of our fluid grade metal repair products with an aluminum oxide to create a non-slip surface where F-150 trucks would go onto the stainless steel conveyor. So it does handle load. In that particular situation, they're reapplying that about every 2 years because over the long term, all those F-150 trucks going over it at pushing out 50, 60, 70 trucks an hour is a lot of load.
Yeah, I know that helps. I appreciate it.
We had Bobby chat in a question. He's asking, what are the most common mistakes made during plate bonding installation, and how can they be avoided?
They're not so much mistakes. It's just sometimes you're in a situation where you can't stop the fluid flow. And when you have that situation, you want to try to use some other techniques. Maybe you want to use a wood plug that will swell up and expand. Maybe you want to use a product designed for the wet, damp environment. But that can make it a little bit more challenging when you can't stop the fluid flow. But that's a great question that was texted in or into the chat box. And keep in mind, if you have questions and you don't necessarily want to ask, feel free to reach out to one of our technical sales consultants via phone, text, email, and we'll be more than happy to come out and do a site visit to make sure you're getting the right materials available for your plate bonding needs. Looks like Clinton Schroeder might have. Clint has a question. Feel free to speak up, Clint.
Yeah, Doug, I was just kind of wondering what's like temperature limitation on these. I guess I don't know if I saw that or not on this material.
Okay. So temperature limitations, it's going to vary from situation to situation. We recently added a product called 101 XHT, which handles high heat up to 356 wet and roughly 456, 465 dry heat. And then as far as cold temperatures, once they cure, most of them can go down to -40. Does that answer your question, or is there something else you'd like? In fact, I'm going to show you a picture, Clint, since you brought it up. I got this Coke can, and yeah, we'll share this picture. Sometimes I like to barbecue on Saturdays, so I'll share my screen. Let's see here. Let me share. Yeah. Okay. And you can see there's our standard Resimetal 101 on top of my barbecue pit at 625 degrees. Technically, that product's only rated up to about 392 dry heat, but keep in mind the technical data sheets are very conservative. And in this particular case, it's not like it's seeing the direct heat, it's just seeing the heat from the barbecue. But inside the barbecue is at like 650.
Okay, yeah, that answers the question. Thanks.
Okay, great.
Looks like Bobby chatted another one. He was asking, what are the labor time savings when using plate bonding versus hot work methods?
Bobby, that's a great question. It's going to vary from plant to plant, industry from industry. Some refineries might have their own fire department on site where maybe they can push through the paperwork a little bit faster to get a hot work permit when they're not welding in a welding area, a zoned welding area. But really that's where a lot of the savings comes in is waiting on permits for hot work. The other thing to keep in mind is if you're welding, you can't weld too fast. If you weld too fast, you overheat the area, you create some stress corrosion, and you can sometimes liquefy the metal, especially if it's aluminum, which doesn't warn you at all when it's ready to liquefy. So that's probably what people like about it, is you can build this up a lot faster if you have a lot of missing metal than you can with welding alloy.
Great, thank you.
Yeah. In fact, we got a special guest that's across the table from me. Any other suggestions, Mark?
Nope, you covered them all. Thank
Okay.
you.
He says I covered them all. Okay, great. Well, thanks for joining in, everybody. It's 12 o'clock, and have yourself a great day.
Thank you.
I didn't say your last name.